Hello, now we are going to look at cylinders and the formulas that we need for cylinders. Because they're a little bit messy and complicated, they are mostly on page 10. Now for the surface area we need to think a little bit carefully about the formulas that they give us, because they give us the curved surface area, but we'll come to that in a minute. So page 10 in our log tables is useful for cylinders. The first thing to think about is that a cylinder is a type of prism. That's to say, if we say take a round bar, like a piece of metal, or if you prefer to think about food, a Swiss roll, if we imagine the cross section, if we cut down through our Swiss roll, it's going to be a circle, and it's going to be the same size of circle no matter where we cut along the Swiss roll or where we cut along the iron bar. And that's what we would call a prism. And this particular type of prism is a circle all the way through. So we know that the volume for a prism would be the area of the cross section, the area on the end, capital A, multiplied by the length of the prism. Now, for cylinders, we tend to have a slightly different naming scheme for the length, because we often think about cylinders as being things like bean tins or cups. And as a result, we tend to think about them as having a height. So instead of a length for our prism, we tend to say h for height. And the area is the area of a circle, as we've talked about, and we know the area of the circle is pi times the radius squared, pi r squared. So subbing in our area, we have pi r squared, the area of the circle, times the length, and we know that we usually call the length of our cylindrical prism h for the height of the cylinder. So the volume of our cylinder, given to us on page 10 in the E-formula tables, is pi, our 3.14 number that we can get on our calculator, times the radius squared times the height of the cylinder. Now the surface area, if we think about our surface area, we know the surface area just means the area of all of the surfaces added up together. So if we think about what makes up a cylinder, a solid cylinder in this particular case, so a closed cylinder or a solid cylinder, we'd have the top, which we know is a circle. We'd have the side, which if we unfolded it flat, would be a rectangle. And then we have the bottom of the cylinder down here, which would be the same circle as the top. So if we unwrapped it, this would be the net of our cylinder. And as with all nets, you can draw it in a few different ways. But this is a way of drawing the net of a cylinder, where we've folded up the top, folded down the bottom, cut down the side, and folded out the curved side of it. And if we think about our two circles, they're fairly straightforward. They're just the radius of the original cylinder. But if we think about this rectangle, I've colored in the top of my cylinder, and I can see that it going around my cylinder, I go around the circumference of the top circle. So if I unravel that, if I roll that out flat, that means that the top length of my cylinder, the top length of this rectangle is the top length of the cylinder, which is going to be the circumference of our circle, of our top or bottom circle. And that means that I just have 2 pi r, circumference of my circle on the top, times the height of the cylinder, because it's just a rectangle, so it'd be length by width for our area. So now we have all of the pieces we need for putting together the surface area of a closed cylinder. So this would be for a closed cylinder. And we'll think about why in just a moment. So for a closed cylinder, because I have included both the top circle and the bottom circle. If I was told that this was a pipe, then I wouldn't have either of these. I wouldn't have a circle at the top and I wouldn't have a circle at the bottom, because a pipe would be open at both ends, and I'd only have the curved surface area. If I was told that I had a glass, like a glass of water, I'd only have the base of my cylinder. And if I was told that I had an unopened bean tin, then I would know that I'd have the top of the tin, the bottom of the tin, and the curved part. So with the surface area in particular, we need to be careful what's the setup given to us in the question? What story have we been told? And what surfaces then are we going to have to add up to get the total surface area? And again, usually, unless they tell you otherwise, when they ask for surface area, they mean the outside surface area, not the internal, not the inside of the can or the glass. They'll generally mean the outside, unless they particularly tell you to include the inside. Now, we have our formulas. We know that they're on page 10, or at least the volume and the curved surface area. So the curved surface area, this one is on page 10. Let's use these formulas now. So first of all, we're going to have this cylinder here. So I can see it's a cylinder. I can see the information that's given to me in the picture. And I'm asked for its volume in terms of pi. So what does in terms of pi mean? It means that I'm just going to work out the normal numbers involved. I'm going to sub in for the radius and the height, and I'm going to leave pi in my final answer. So it doesn't go in the calculator for me this time. I don't put it in as 3.14. I'm just going to leave pi as part of my answer. And we'll look at that now. So I'm asked for the volume. I recognize I'm dealing with a cylinder. So I go to my log tables and I immediately write down the formulas that are connected to cylinders. So I have my volume that I'm asked for here. And in a harder question, if I couldn't see how to make progress, I'd also write down the surface area and fill in as much information as I can. Now, as to filling in as much information as I can see here that I'm given, I have to be careful with the way that information is given to me. This is the diameter of this cylinder, but I know that my formulas all work with a radius. So I need the radius. Well, the radius is just going to be half of that. So the radius I'm interested in is going to be 10 meters. So we need to look at the information and read the information we're given quite carefully. So I have my volume, and I know the diameter I was given was 20 meters. Therefore, the radius is going to be 20 all over 2. So the radius is going to be 10 meters, just what I did up in the image here. So I've filled in the information on my diagram. I've written down the formula that's connected to what I'm asked about. And I've now gotten what I need. Do I have everything? I need the height as well. And the height is just given me directly is 8 meters. So now I have all the information I want. So the volume is equal to pi multiplied by the radius squared multiplied by the height. Always sub everything in brackets. And when I put that into my calculator, we remember again, we're dealing with in terms of pi. So I don't want to actually get rid of this pi. I just want to know what this number is. And I'm going to have a number times pi. And that's going to be my final answer with my answer in terms of pi. It means that pi gets left alone. It's there in my final answer. So I end up with, I put 8 and multiplied by 100 squared into my calculator. And I end up with 800. And then I have multiplied by pi. And that is my answer in terms of pi. So I didn't put pi into my calculator. I just put the numbers in, and then my final answer has pi multiplied by it. And I know I still need to include my units. It's a volume. So that means that I need to have, in this case, meters cubed. So my units were meters, and I'm dealing with a volume, so it's cubed. So now we can go on to our surface area. And in this case, from the context, it looks like I have a closed cylinder. So I remember then that I'm going to have a circle for the top, a circle for the bottom, and I'm also going to have this rectangle from where I take the curved surface area and fold it out flat. So I have the areas are going to be my top, my bottom, they're both circles, plus my sides. So my top and my bottom are the same. I have my radius already, it's 10 meters. So my pi r squared plus my pi r squared, my top and my bottom, plus my side is 2 pi r for the circumference of the top circle, multiplied by the height h. And I sub now in, I have my radius is equal to 10 and my height is equal to 8. And I sub all of that in. and work out my answer. And in this case, for the surface area, I'm asked to get it to 2 decimal places. So this time I go to my calculator and I press the pi button. So second function, and then down on the bottom row, you'll see the pi button. And let's multiply that out. So I sub all of this into my calculator and I make sure everything goes in brackets. When I'm in the middle of a question, I always go to 4 decimal places, and then in the final answer I'm asked to go to 2 decimal places, which means that I round here, and in this case I don't have to do anything because 3 is less than 5, so I end up with my 1130.97, and its units are going to be meters, because those are my units, squared. And that's what we need there. And then if we're given the information in a slightly different way and we need to go back and find a height or a radius, we're going to do very similar work. So if pi is equal to 3.14, so that's what my pi value is going to be when I put it in my calculator, find the height of the cylinder with radius 30 meters and volume of 14,130 meters cubed. So let's write down the information I've got. I have pi is equal to 3.14. I have a cylinder. So I'm going to write down my formulas that I know for a cylinder. So I write down all the tools I have. And then I have the radius is given to me as 30 meters. The volume is given to me as 14130 meters cubed. I've now taken all the information in this English sentence and I've put it all down so I can see all the tools are available to me. I have this number information and I have these formulas that are connected to this shape. And we want to always do this because this is us starting out in dealing with formulas and having to deal with complicated formulas. This builds on itself over time, and we want to develop the right instincts for being able to do this well as it gets more challenging. So the volume formula and the surface area formula, because I can see I'm dealing with a cylinder, so these are the tools I have available to me. And if we do that, we can usually make progress. So I can see now all I need is the volume formula, because I'm asked for the height. I should actually write that down. Height is the thing I'm looking for. And I can sub in to the volume formula, because I know the volume, I know pi, I know the radius, and I want to find the height. So I look for the formula that has only one unknown, looks for the thing that I'm missing and has everything else. So let's sub into that formula. So the volume is equal to pi or squared h. I know the volume. I know pi, 3.14. I know the radius is 30, and that's squared. And the height is what I'm looking for. So let's put this bit in the calculator to know what my coefficient of h is. So I end up with this number when I put this into the calculator, and I divide both sides 2826, because I want to know what 1 h is, and currently I know what 2826 times h is. So I divide both sides of my equation and I end up with h is equal to 5. So the height of my cylinder is 5, and in this case the units I'm working with is meters. So that is what we need for our cylinders. Again, the key takeaway is write down, if you see you have a cylinder, write down your volume formula, write down your surface area formula, and be careful of what the surface area formula in particular should look like for the question you're asked. Write down all of the numbers that you are given, fill in the diagram as best you can, and from all of that you'll be able to sub in and solve the problem. And that's what we need for now.